think just drop this little tiny thing out of there and put it in here and go put it away for, I don't know, another eon. Alright. There we go. Here's Tyrell's new spindle gear. That's easy enough to put in there if it needs to actually be in there, but I almost tend to think that that was an accident. Hard to say. I really don't know. Alright, as you can see, we did hit this with the lap, and after we hit it with the lap, we went in there and we rubbed the bronze and all the teeth all the way through here with the wire wheel, so it kind of takes the satin appearance to that bronze there, so it's not so bright like some of the pictures that I posted or have that you've seen of it fresh out of the mill. Alright, so we're gonna make sure that this is clean. We're just rubbing. We can hear those high spots. Okay, now she's smoothing it right out. And a little bit raised right around there. Those are coming out pretty crisp. Okay, we've completed Tyrell's gear, and now we're going to go ahead and we're going to braze repair this break that he has in his arm. Now this arm holds the, I guess this would be the input shaft for the feed box there, or around the spindle. I'm not sure which one, let's see. It's on the back of the lathe. This would be the back headstock that way, I guess. Here's your oil feed. And then you can pitch this in this direction here, and then the gears, and then I think the gear train goes into there, into either the quick gearbox or directly onto the feed rod. I'm not sure. You know, I've never seen the lathe. I've just seen a number of these arms. He's had a repair here once before. This has been brazed up. Looks like a nice successful hold. It's been remachined flat with the surface. I'm going to pull this pin out of here, and then we're going to V and prep all the way around both sections. Now this is broke right next to that hub, and most of that, it's real hard to braze inside a pocket. Okay, and what I might do is actually stand it up like this and then braze in from there around this direction here. So I'm not really trying to blow into there. I mean, no matter what, it's hard to do that, but I'm going to put almost all the prep around the outside, because that will be and ensure the most contact of joining these two pieces together. Alright, and you can see that this braze inside here it didn't flow out into the corners because it gets blocked into the flux. Actually creates a little bit of a pocket, and you can see outside here braze will flow real nice to the outside. You didn't quite fill it up right there, but it's still in good shape there, and it appears not to be weak in that point. So let's go ahead and get started. I'm going to go ahead and pull that out real quick and come back and do a little grinding here, and then we're going to set it up. After I pull this out, I'm going to put a straight edge across here, and I think I'll be able to clamp those things completely straight. And we'll be doing in kind of a little tack area here. We're also going to check and see this surface, and this surface all the same. We'll mic this up just like this all the way down. We'll see if that's parallel. Couple things that we can check and that we can hold it, because I'm going to go ahead and do this braze repair, and then I want to do nothing more than just kind of like touch it or kiss it off on the sander, and then and it'll be all ready to rock and roll. Alright, I just finished wire wheeling the paint, the rust, any of the film and build up as best I can get in here with a wire brush. This is a pretty clean break, meaning I can hold this part up here and it registers it pretty darn close. These bosses here are uniform as they go. Okay, there's actually a little taper about 3/1000 from here through the three of them out to the end. That means I can use them to locate the flatness of this. I lapped these surfaces here. Okay, this fits in here very nice. These three bosses are the same thickness, maybe 3/1000 from this one here to this one here. I'll be able to use these flat surfaces to locate this break. And I went ahead and I did a quick lap on all of those to prove that they are completely flat, including these three right here, all simultaneously. So their repair and this fix right here, whoever did this, they, did a pretty decent job. I decided, instead of trying to blow into here how tight it is, I am going to grind back and create 100% weld build from the outside and just leave a tiny bit of the inside left there to locate the actual fracture itself. And then clamp these with a parallel and then braze that up on the outside. Okay, we're going to stay a little bit away from this boss here, but I'll be able to grind this almost 100% back so that I'll be down so that we can get that close to 100% full penetration of braze. Alright, I'm going to get it ground up and then we'll come on back when we get set up to braze. Okay, I've got both pieces prepped, and you can see how much I actually left right around that inside edge right there, and even up here. Even though this is actually not angled back too much, but I want to make sure I leave that whole hub on there. But when you do put these pieces together, and they will match up perfectly just like that right there. So our first initial brazing will be to put them on a flat surface, clamping those three pieces in line, and that crack set up there exactly like that, and then come and then grab a braze on both outside edges right here at these corners. Then roll it on over, and then we'll go ahead and we'll be brazing that all the way around. This will be set up at this point at this time here, and that there'll be the flat surfaces will be clamped together there as well. So just an initial to make sure that we do have that perfect alignment right there, and then turning it over, and then it'll be a full braze all the way around on here. Alright, we got our little vise here, and we have an old vise jaw that came off of an old mill vise. It's a precision piece, and we use it to clamp together lots of things when we're brazing and welding and stuff like that. So I use it as a tool in a weld shop, and I keep it kind of debris free. And anyhow, we are clamped tight, and we want to go ahead and put a little braze on each of these corners right here, and then we're going to go ahead and we're going to flip this over on our parallels and then we're going to go for the big braze. And we want to go ahead and first off we're going to do some preheating. Just want to bring this whole thing up to about 400 or 500 degrees. Okay, we're reading about 400 or 500 degrees in there. So warming up our rod here. Grab my face wheel. This will be like a vertical little tack here, both sides. Put another one over here. Okay, we're going to shut this off real quick so we can roll this right on over. And everything's pretty well preheated on the bottom there. It includes these two clamps. I can feel those. Alright. I'm going to roll this right on over here. And I'm going to clamp that one there. And this one here. Okay, now we can get right to business and work from here to here. We're going to pretty well give a nice flow. We're going to work from the side up and then go from the side up. We like to go vertical. We know that we can see the path in front of us and we're not going to be overlapping onto something and not joining. Let me move you around to the other side here. Okay, hopefully you can see a little better from that angle on that side there. I'm not bothered putting the auto pinning lens there. Okay, I'm happy with that weld, and I'm not going to concern myself with the underside at all. I believe that I've penetrated through there, and right now, for the next couple hours, I'm going to go ahead and we're going to wrap this up into this blanket here, and we will come back to it and see what it looks like in another couple hours. Here we go. Okay, let's go ahead and uncover this. It's about 6 o'clock in the evening here, and we just had dinner, and this is still pretty warm. Well, it's been sitting in here for a while. I could hold the C-clamp for about that long. It definitely has cooled down some. Let's get our gloves on here. A little bit of flux there. I like that. We're gonna see if I can find my little chipping. Here it is. That's pretty good. The flux is pretty heavy, just in a couple areas right there. That looks really good. I like that. Okay, a little bit of dressing and sanding up, and we'll go take a quick lap on this, and we'll see how flat we are. That's awesome. Okay, I just went ahead and finished wire wheeling this outside surfaces here after I took a flapper disc, kind of put it down here on the wood block and kind of shaped out, dressed it up. So you could paint that up and it would look pretty close to the same. And you can see where my flux was sweating in through the weld, the braze, the full prep. And you can see that area there. One little hollow right there. I'm not going to worry about it. It's not worth creating more heat and maybe taking and stressing this thing out. We're going to go in and we're going to hit on the lapping. We're going to knock that little bit of flux off of the surface right there. And we'll be able to go ahead and put that rod back in there. And this thing's ready to go back to them. Okay, I'm going to see if I can reach in here, let this overhang the table here. Alright, I'm hitting on all 3 spots there. I'm not rocking. A little bit more on the inside than the outside of there, but those two, this is on the outside here a little bit. Pretty darn flat. Okay, now we have a little bit of flux on here, so I'm hoping that we'll get that knocked off of there. There's a little chunk of it. Oh, ripped the paper. Alright, let's see if we can knock or scrape that off of there. Some of it came off. There we go. A little bit there, we're hitting there, we're hitting 3/4 of there, and we're hitting over the top of there. Well, I'm gonna lift the paper. About time for new paper on here. Okay, I'm happy with that, Terrell. You're gonna have a pretty good arm there that you can throw your stuff back on there, and you're gonna have relatively straight alignment with it. Not bad for a piece that's been broke twice. All right, we're wrapped up on your job there, Tyrell, and we're getting ready to box it up and send it back to you. And I'm gonna be able to fit it in a medium rate box there. Have it wrapped up good, and it'll be on its way here shortly. Wanted to touch base is that sometimes during a video I might touch into something, might seem to miss details, and that's what the comments is all about. So get in there and make some comments. And the next gear job that comes along the way, what do you want to know a little bit more about that? As far as all the technical data that you need for gear making is laid out in the machinist handbook and gives you a lot of detail. So I hope by me skimming over some of the processes of me actually measuring and what I'm looking for, and what was really helpful is I did have a sample to go on. And how you compare your new one with your old one, and even going the extra step and using the thread PD wires to kind of do a double check and stuff like that. Those are things that I gotten used to, just because when it comes to cutting a gear, and especially if you don't have the lathe, the machine, and you can't quickly assemble on a spindle and check your backlashes and all these things that are really important on gears, to actually see what the riding fit is. It is really important to create it as close to the sample as possible. A lot of things that wear out, like lead nuts and lead screws and stuff like that, sometimes making match sets and having both components together are just as important. Anyway, let's get back to Tyrell's job here. We made one gear, we repaired the other gear. After I hit this on a wire wheel, it really did mellow out the bronze. It's not so pronounced, and it looks antique-ish kind of right now. It's kind of cool. I enjoyed the repair as much as I did the new, and it was nice having the matching gear here to compare and actually have all three of them put together, so that even doing all of our dimensions that we did as far as root, outside diameter, somewhere in the middle of the working depth with the PD wires and things like that. The arm, really glad, one, that this repair was done pretty true, and I could see that by the lap contact surface on the paper there. And I was really glad that I chose to do it the way I did and give it a full prep on the outside. And I actually, you can just see where some of the flux and very tiny little bit of the braze actually seep through, and this is going to be a great fix. I think this is probably a crash item, and that's why it broke. Normal usage on this kind of component does not create a break. Anyway, I'm going to get this all in there. Tyrell, as far as the cost of this job, you know, the cutter cost me about $100 to send it here, and we probably had about 35 bucks for a slug of material there, and a little bit for the braze there. Hey, minimum 150 bucks in it. That's a good deal, I would think. Everybody else that would like to see more jobs like this and somebody get a sweet deal and this kind of workmanship at a bargain price and give you something to learn a little bit more, log on to my website, click onto that sponsorship, and hit me up with a few bucks there. That will keep the motivation going to be as generous as I am with my videos and also jobs like this. This did take quite a while, so any mail car jobs, don't think that it's going to be a hot job, because it's not all going to work out that way. I had a little faster, around the same time we had the mat tracks. That's still, I was barely getting it back to him for the next running season on the mat track, but you know, I did get it there, and he had some other things, so it kind of fit in his timing and schedule as well. And Tyrell said, hey, don't worry, I piled everything up in the back corners, and now he's going to get this. Now he's going to be digging it out, and he's actually going to have something to play with this winter. So it's all good, right? Get her done.